Our next question is from GATE 2014, Fluid Mechanics for 1 mark. In case of pressure driven laminar flow of a Newtonian fluid of viscosity mu through a horizontal circular pipe, the velocity of the fluid is proportional to. Let's start with the solution. For this we use Huygens-Poiseuille equation. Huygens-Poiseuille equation is used in laminar flow. Delta P by L, where L is the length of the pipe and this is 32 mu V upon d square. From this you can see here mu into V. Everything is constant, delta P is constant, L is constant, d square is and 32 also constant. So from this we get V is equal to mu inverse. From this you can see here option C is correct. Option C is correct. So now our next question is, which of the following statement are correct? For rheopactic fluid, the apparent viscosity increases with time under a constant applied shear stress. Yes, it is right. Remember this. So option P is correct. And we will see for pseudoplastic fluid, the apparent viscosity decreases with time under a constant applied shear stress. No, it is wrong, since you can see here in this figure, apparent viscosity does not depend on the time in case of for the pseudoplastic fluid, right? It depends on the shear rate, right? In case of for option R, for Bingham plastic fluid apparent viscosity increases exponentially with the deformation rate. You can see here in case of Bingham plastic fluid, it is you can see here the apparent viscosity is constant. Why? You can see here for apparent viscosity we will write this equation from the power law model. Tau is equal to mu du upon dy to the power n minus 1 into du upon dy. So you can see here tau is equal to eta du upon dy. From here eta is equal to mu du over dy to the power n minus 1. This is the apparent viscosity. You can see here if tau versus du upon dy, since it is a shear rate, and it is a shear stress, right? If we draw the plot and we are getting the straight line, you can see here we are getting the straight line in case of Bingham plastic fluid. That means eta should be constant. Now we will see further. For dilating fluid, the apparent viscosity increases with increasing the deformation rate. Shear rate or deformation rate are same. So you can see here, if you draw the line here and you will see the slope, and if you draw again a line here and you see the slope, you can see here slope is continuously increasing. From here you can see here, if slope is increasing, that means the apparent viscosity, slope is nothing, it is apparent viscosity, so that means apparent viscosity is increasing. S is correct. For dilatant fluid, the option S is correct. The apparent viscosity increases with increasing deformation rate. So P and S are correct. So option D is correct. Option D is correct. Our next question number 17. Actually it is from mechanical operation, but I made this question is here. I am solving this question is here, otherwise I have to make a separate video for this. So we will check this. In order to produce fine solid particles between 5 to 10 micrometer, the appropriate size reduction equipment is. For this we will use fluid energy mill. Fluid energy mill do the ultrafine grinding. We will check next question. Slurries are most convenient pumped by. It is generally pumped by the diaphragm pump. Option B is correct. So thank you. Please make sure to like, share and subscribe my channel. Thank you.